Thanks very much to Heather for sort of setting the stage for what the Provincial Groundwater Monitoring Network is and what the goals are and how it works. So just to briefly summarize, it is a province-wide network that is designed to monitor baseline water level and chemistry changes over time. It's got over 500 wells across the province, but currently it lacks a framework for correlations in terms of the geologic layers or specific units that wells are screened into. And that's where we come in at the Ontario Geological Survey. We're trying to provide that necessary information for correlation so you can compare apples to apples when you have specific questions about a single well or a group of wells within the network. Now at the OGS, we have a lot of different products that are readily available. The map on the right is showing you a list of multiple of those, and the table on the left is just showing you how many of the PGMN wells can be attributed with that information. So that was the first phase in this, is just collecting all of the readily available information and bringing it into one place so that when you download PGMN data, you'll automatically have access to all of the information for that well site that is available from the Ontario Geological Survey. But those are just two-dimensional maps, and as we know, we need a third dimension within these systems. So we're going to take a quick look at how we're going about assigning stratigraphic information for both the wells open hole in the bedrock, as well as wells that are screened within quaternary sediments. Now, for the bedrock, they're actually in a pretty good place because over the last 15 years or more, we've been very busy in developing a standardized framework for the province. So the chart on the left is the stratigraphic chart developed by Frank Brunton and is currently being expanded upon. We heard a little bit about that on Tuesday from Katie. And so there's currently a well understood nomenclature and understanding down to the formation level for all of the Paleozoic bedrock units. On top of that, we've had a long history of working on the geochemistry of different flow systems, both in sediments and in the bedrock. And the map on the right is showing some of the results of that when combining geochemical signatures of groundwater with known geological features such as karst occurrences across the province. Then this work really culminated over the last few years from a collaboration between the OGS, the GSC, and Oil and Gas Salt Resources Library team, where they developed a fully three-dimensional model of 57 bedrock formations across southern Ontario. And what this does is allowed for automated extraction of formation level stratigraphy for all the bedrock wells. So anything within the dashed black line in the map on the right, we can have an automated process to gain stratigraphic information from that. But there's a little bit more work than just that because there's elevation discrepancies between true ground elevation, the mesh elevation in the model, and the elevation from the raster that we generated to be able to extract that. And as you can see, there's a whole host of other wells that are going to require manual interpretation for both Eastern Ontario and in the Shield. So that work is ongoing and going to be carried out throughout the summer. In the Quaternary, things are a little bit more challenging. We do have a lot of great cored boreholes, and these are kind of the gold standard for stratigraphic assessment, especially when they're accompanied by geophysical data. There's almost 100 wells in the PGMN that are within a few kilometers of cored boreholes, and 29 are installed directly into one of these cored borehole sites. And that's about as good as it gets when you're trying to assign stratigraphy. From those individual borehole logs, we develop large-scale regional cross-sections that guide our understanding and interpretation of the subsurface. And where we've got published three-dimensional models, you can actually just extract the information from the screen depths directly from the model and assign a layer to that. Where it gets challenging is that we've published multiple models, and through that work, there are a whole host of formations and modeled layers that have been identified throughout the province. And it's really a little bit cumbersome to try and carry this many throughout a framework for trying to understand the entire province's stratigraphy. So we have to try and boil it down. So what we're looking at here is all of the available units that we've modeled, but I'll just sort of highlight some of these recurring packages that are highlighted in the colors. And so that's sort of the framework we're going to use to try and distill this information down to something that's a little more palatable but still useful. So what we're doing is trying to simplify the conceptual cross-sections shown in our three-dimensional models down into a consistent, standardized framework. And that takes us to a system where we've got 17 layers that I think adequately describe all of the quaternary glacial sediments, whether you're in Windsor, Ottawa, Thunder Bay, or the far north. And what this does is it sort of combines, it eliminates terms that are geographically based or temporally based and sort of combines them into something that accounts for the hydrostratigraphic and the morphologic setting of the different deposits. So we'll quickly give an example from the Orangeville area and sort of show exactly what this looks like. So here's our model from the Orangeville area simplified down to one layer for just overburden and bedrock. Here it is simplified into 3 layers of post-glacial and pre-glacial materials. Here's roughly what it looks like in the model we built with the Geological Survey of Canada for all of Southern Ontario. And then this is sort of what it looks like in this new 17-layer system. And what we want to do is not just assign a stratigraphic name to it, but also provide the sort of broader spatial context. So within this, we want to add pictures of this in terms of what it looks like on a more local to regional scale. And just before this work is done, I just want to highlight that if you have a PGMN well that you're curious about in any of those areas shown in green in Barrie Oro, Orangeville, or Brantford Woodstock, you can actually access our live beta cross-section viewer, and you can get a good understanding of where your well sits within the stratigraphy just by using that tool, which just became available last week. So there is a bit of a limitation here. We're taking out the temporal aspect of hydrostratigraphic units, so we are losing something because we get these repetitive packages. We're not actually able to use this on a sort of model scale basis, but it is very helpful, I think, in terms of understanding where we are within a sort of surface to subsurface approach. And I think what it does do is really sort of connect the stratigraphy to the function of those stratigraphic packages in terms of what they're doing in terms of recharge, discharge, and confined or unconfined flow systems. And while we are simplifying this, we are carrying forward all the names that are currently in use so that we have that translation table available. Because as we all know, we've got more than enough names right now, and it feels really bad adding more, but we are going to keep the ones that we currently have. And so just to give a quick example of what this looks like, here's an example of our seamless superficial geology map. And one of the issues with this map is that it's coded based on the genesis of the sediments and not the stratigraphic setting of each deposit type. So now that we have this framework, we can recode our current maps so that they're showing the stratigraphic position of the deposits. And then from there, we can better evaluate things as we move into the subsurface. And ultimately, what we want to do with this project is develop a single database that contains all of the necessary data from the PGMN itself on the identifiers and geographic and elevation and depth information, but then move forward and append all of the available geological data. So here's an example just showing that, we can provide information as to whether or not there's LIDAR, the types of surface materials that are available, whether or not those are high or low permeability. And then we've dived into describing the regional landform type, the local landform type, as well as a correlation back to the name of the previous names to the landforms, as well as assigning the surface stratigraphy. Because with this example here, all 3 of these wells that are open hole in the bedrock occur within the same physiographic region. They have the same surface material type, but the local setting, whether they're on a bedrock high or in a valley, and the stratigraphy below that uppermost unit is going to potentially have a major impact on what that well response is over long terms during droughts and flood systems. So moving forward, we've got the LIDAR mapping, and then we are also assigning the manual stratigraphy in terms of the formation names, but also whether or not there's a confining unit, either from the well record or others, such as our models. And then we've also got the information that's available from our published 3-dimensional models. So these are examples from the 2 province-wide models, the superficial model and the bedrock model, and just looking at where we have agreement or disagreement between those and trying to go through that and assign the best available information. So that work is done for most of the sediment cored wells, sediment hosted wells. It's ongoing for the bedrock wells, and we're sort of always looking at ways to improve our understanding of the settings of each of these. So just to wrap things up, we're currently in the process of QA and QCing our information that we get from these 3D models, as well as individual well records outside of those model areas. We're looking through the database and developing it, trying to make sure we have all of the most relevant information available to you. And then in the next few months, we're going to begin the report writing, outlining our methodology and the findings. And ultimately, this is going to be a product that's available as a database, but also as a spatial product that will be served through the OGS's Geology Ontario, as well as Ministry of Environment's Provincial Groundwater Monitoring Network portal, where you can access the data through either one of these so that they're more complementary. So there's quickly just the references, and I assume we're going to be moving forward in the name of time. I just want to leave the QR code up here in case you did have interest in using our beta cross-section viewer if you have questions about the quaternary geology in the different model areas listed there that we have completed viewers for. So thank you very much for your time. My email address is right there, and I hope everybody has a great day enjoying the rest of the talks. Thank you.